Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Tiara Putri from Telkom University Bandung. I am one of the author of this paper. The paper title is Indonesian Ethnicity Recognition based on face image using Uniform Local Binary Pattern, ULBP, and color histogram. And this is what my research has been looking at. Let's get started. The human face is a biometric attribute that contains information such as age, gender, and ethnicity, which can be very useful for facial recognition. Even though a person's face provides various demographic information such as gender and age, ethnicity remains one of the fundamental attributes that cannot be easily disguised. An example of the utilization of this system is video surveillance system. Ethnicity recognition is a key component used at security checkpoint because it can support image search requests. Also, ethnicity recognition can narrow down the database search, thereby simplifying the searching process. Therefore, it can be said that ethnic recognition is important. Identifying individual characteristics based on facial image has been widely studied in the field of face recognition. However, the research of Indonesian ethnicity is still not available. Therefore, we propose a system of Indonesian ethnic recognition based on the face periorbital area because it is the most dominant area on the face. We combine two features. The texture features obtained using Uniform Local Binary Pattern, because it is a texture descriptor that can be used for facial recognition, and the color feature obtained using color histogram, and as the classification method, we use random forest. This research used a dataset from Multimedia Laboratory, Faculty of Informatics, Telkom University. Each data had been labeled with Sundanese, Javanese, Banjar, Buginese, and Malay ethnic. The dataset consists of 2,290 periorbital area images, size around 200 and 400 pixels. This is dataset sample for each ethnicity. This research consists of two steps, the training step and the testing step. This is the flow diagram of training step. The first is input image. Then pre-processing for ULBP, we convert RGB into grayscale, and for color histogram, we convert from RGB to HSV color space. After pre-processing, we perform feature extraction of ULBP by doing a neighbor comparison, then produce a binary series which is converted to decimal, and feature extraction of color histogram with HSV color space. And the last, we do classification to get the class prediction of each image. And then this is the flow diagram of testing step. The difference between the training and testing step was in the classification process. In the training step, we train the classifier to obtain the classifier model using the training set. In the testing step, we classify the testing set using the model obtained from the training step. The experiments conducted in this research consist of 4 scenarios. The scenario 1 is parameter tuning on ULBP method. We use cross-validation with a k-value of 10. The parameter we used were P of 4, 8, and 16, and the radius were of 1, 2, and 3, and the block size used to split were 2 by 2, 3 by 3, 4 by 4, and 5 by 5. We can see that the best accuracy was 89%, obtained using ULBP parameters of P equal 4 and R equal 3 on block size 3 by 3. The block size 3 by 3 precisely separated facial features in the face periorbital area, such as the eyes and nose, into smaller parts, so that they provided more information than the other block size. In scenario 2, we do parameter tuning on color histogram method. We can see in the table the best performance is on S and V channel with 16 bins. In this research, the A channel didn't affect accuracy because hue used to distinguish colors. Meanwhile, the image used in this research didn't have various color because the skin color in each ethnicity in our dataset tends to be the same. In scenario 3, we compare the classification method performances between random forest and support vector machine. Random forest was our proposed classification method, and we compare it with SVM because SVM is a good classification method that robust to noise. We use the combination of ULBP features and color histogram features as the input of the classification method. We compare random forest with 403 and SVM with regularization of 0.1, a gamma of 0.01 with a polynomial kernel. We can see that random forest got a higher accuracy of 98.60%, which is show that the random forest method is better than SVM in our research. Furthermore, we look for the optimal K value in cross-validation using the elbow method. The optimal K value was 5 for random forest with an accuracy of 98.25%. Based on the experimental results, the color feature had a more dominant influence on ethnic recognition. In scenario 4, we compare the system performance of using a facial area and the periorbital area. We extracted the features by combining ULBP features and color histogram features using the parameters obtained in the previous scenario and random forest as a classification method. The results showed that the face periorbital area had more influence on Indonesian ethnicity recognition than using all facial area because the periorbital area around the eyes to the nose is the most dominant area on the face and has more features that can differentiate the ethnicity of people. The accuracy value was obtained from average accuracy of each iterative fold at value of k equal 5. Of all ethnic classes, the class with the most misclassified was the Malay class. There are 4 wrongly classified images in the Malay class, with 3 images classified as a Banjar class and 1 image as a Sundanese. In this research, misclassification occurs because the misclassified image has features similar to the predicted image feature. The feature in the prediction class have a smaller distance than the actual class feature. Distance is calculated using Euclidean distance. This is the example of misclassified class. You can see that the Malay class image classified as Banjar class has an average Euclidean distance in the prediction class, which is smaller than the average Euclidean distance in the actual class. Therefore, the image of the Malay class is classified into the Banjar class because of the closer distance to the Banjar class. The evaluation result for the system overall performance calculated from the average value at k equal 5. The model that had been built had the best performance accuracy of 98.25%, precision of 98.28%, recall of 98.25%, and F1 score of 98.25%. In this research, we had built an Indonesian ethnic recognition system based on facial image using uniform local binary pattern for texture feature and color histogram for color features, and random forest as a classification method. We used 2,290 facial images that consist of 5 Indonesian ethnic, Javanese, Sundanese, Banjar, Beginese, and Malay. From the research, we obtained that the optimum parameter in ULBP was the number of neighbors P equal 4, the radius value R equal 3, and the block size was 3 by 3. We also obtained the optimum parameter in color histogram was by using the SV channel with 16 bins, and for random forest was the number of 3 equal 400. We obtained that the best area in the face image for ethnic recognition was the face periorbital area, which is the area around the eyes to the nose. We obtained the best accuracy of 98.25% based on the experiment result based on finding the k-value using the elbow method. With precision of 98.28%, recall of 98.25%, and F1 score of 98.25%. So that's all my presentation of my research. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.